In this video, we're going to be talking about confidence intervals, specifically about point estimation. Now, suppose we wanted to estimate the proportion of blue candies in a very large bowl. How might we go about estimating this proportion? We could take a sample of candies and compute the proportion of blue candies in our sample. We would have a sample proportion or a statistic, a single value for the estimate. So let's talk a little bit more about point estimate. The point estimate is a single number or a statistic based on a sample data that is used to estimate a population characteristic. So the point refers to a single value on the number line. So this is our point estimate. Now, a point estimate isn't always to the population characteristic due to sampling variation. Different samples may produce different statistics. Let's look at an example. The paper U.S. College Students' Internet Use, Race, Gender, and Digital Devices reports that the results of 7,421 students at 40 colleges and universities. The sample was selected in such a way that it is representative of the population of college students. The authors want to estimate the proportion P of college students who spend more than 3 hours a day on the internet. 2,998 out of the 7,421 students reported using the internet more than 3 hours a day. So that means that our P hat is going to be 0.404. This is a point estimate for the population proportion of college students who spend more than 3 hours a day on the internet. Let's look at another example. The paper, The Impact of Internet and Television Use on the Reading Habits and Practices of College Students, investigates the reading habits of college students. So the following are observations that represent the number of hours spent on academic reading in 1 week by 20 college students. Now, if we create a dot plot here, it suggests that this data is approximately symmetrical. Now, if a point estimate of mu, the mean academic reading time per week for all college students, is desired, an obvious choice of a statistic for estimating mu is the sample mean x bar. However, there are other possibilities, a trimmed mean or the sample median. Let's take a look at those. Now, for our sample mean, we're going to have x bar equals 14.36. Our sample median is going to give us a value of 13.75. And our 10% trimmed mean is going to give us a value of 14.39. Now remember, this is going to be the mean of the middle 16 observations because we're taking off the 2 lowest and the 2 highest. So, how are mean and median related in a normal distribution? So which of these point estimates should we use? So let's talk about choosing a statistic for computing an estimate. You want to choose a statistic that is unbiased, that's accurate. Now, a statistic whose mean value is equal to the value of the population characteristic being estimated is said to be unbiased statistic. So let's look at some graphs. Here we have 3 examples. Notice where the location of the true value is. In this example, the middle one is unbiased since the distribution is centered at the true value. Here, this example is unbiased since the distribution is centered at the true value. However, The example to our left is biased, since the distribution is not centered at the true value. Now we also want to choose a statistic with the smallest standard deviation. So let's go back to our examples and specifically the two that were unbiased. Here we have our unbiased, but it has a larger standard deviation, so it's not quite as precise. However, here we have an unbiased value or estimate, but it has a smaller standard deviation, so it's more precise. So we would want to use that one. Now, if the population distribution is normal, then X bar has a smaller standard deviation than any other unbiased statistic for estimating mu.